afternoon. Thanks for joining. I know it's been a long day. I guess you rejuvenated yourself with a cup of coffee, so you're with me for the next 50 minutes, maybe only 45 minutes. Yeah, I have a topic for you. The title is named Down the Ivory Tower Towards Agile Architecture. I know there have been quite a few great and interesting talks on software architecture today, so there will be some slide overlap, I guess, but you know, rehearsal is always good. Hearing things one or two or three times is always good to sink in, right? But I think I also brought some practical advice from my software projects or software projects from my colleagues. My name is Leander. Yeah, this is where I live down here, the green stuff. This is Austria. So I live in the very, very southern corner of Germany. Small town called Rosenheim, no one knows that one. This is where I studied computer science, 26 years ago. Our headquarters, the company is called Coavia. I'm the managing director and CTO there. Our headquarters in Munich. And what we do is we are a custom software provider, right? We design, build, and operate custom software solutions for DACH-based enterprises, insurance, automotive, retail. Doesn't really matter. Interesting, big systems, you know, with usually big teams, 60, 70 developers working there. I'm a software engineer architect myself. I'm not the classical manager type. And nowadays, I also teach in my hometown. This is where I studied computer science initially. I'm there to teach software quality assurance. And many of the stuff I tell you today is also from that lecture, but I promise you it's not going to be a lecture, okay? Now let's start with the topic. Yes, I already said I'm kind of old, right? And I'm in the business for quite some time. And the old ones here know there have been times where agility was not even invented, let's say, right? We had like strict waterfall type or V model type projects where you had like at the beginning, you wrote tons of paper, right? You did this big upfront design thing. You had a rough concept, then you had a fine concept, maybe a technical concept. So you wrote loads of concepts, loads of paper, 300 pages, Word documents, usually, I guess, back then, where you kind of envisioned the system, where you made like a conceptual architecture. You thought about the technology you want to use. Maybe you thought about how you want to operate the system you want to build back then. So that usually took like, I don't know, half a year. At least. Then you've written down that everything, then you started implementing things, maybe for 1 year, right? And then after 1.5 years, you realized, okay, times have changed, we just built the wrong system. This is kind of, if you want to look bad on waterfall, but there already have been a few good points, right? At least you wrote something. Yes, maybe too much, but it made you think about the problem. Yes, it took you too long to think about this stuff, but at least it did something. And well, at least for me, I can say I did waterfall projects that were successful, that didn't go down that, you know, the bad path. So we were able, and if you did that right, you were able to produce quality software and quality projects and deliver them in time, in budget, and quality. Now this talk is about ivory tower architects. Back then, we had something called the ivory tower architect. I mean, no one really said he would be one, but if you operate or if you work for large enterprises, I bet you there were ivory tower architects, usually pretty old, maybe gray hair. Last time they wrote a line of code, 10 years ago, and they made like hard decisions, right? When you would have asked them, I need to store some data, how should we do it? The standard answer would have usually been, well, use an Oracle database. So here's my first small story. At a large automotive customer, we had to implement a huge system. We knew the data we want to make searchable is really huge, 50 million cars. I don't know, 2 million different repair documents, so different types of data. So think of a huge network of interrelated data types. So we did an MVP. First thing we thought, hey, that sounds like a graph database problem, so let's implement a small POC, Neo4j. Back at the time, we loaded the data, didn't really work, performance was too slow. Okay, we thought, well, what's next? Well, it's kind of a search problem. How about we use an index database? Apache Solr in our case, Elasticsearch was really young back then. We implemented the MVP. Performance results were really great. We thought like, okay, this is a bit unusual, right? To stick like originally relational data into an index database, like a large table thing, but it really worked. So guess what? We went to this Ivory Tower governance board and we said, yes, we have a solution for our problem. We have the solution for this thing here. And they said, no, you can't. You have to use an Oracle database. And then we said, yeah, but it's not the right decision. It's not the right technology for this use case, for this problem. It took us like 4 months discussing and arguing and building another prototype that showed that Oracle database would not have been the right decision because it's super slow, storage would be tremendous, indexing time is definitely not ideal. So we did a full proof of concept, compared Oracle to Apache Solr, and then finally, after 4 months, not doing anything besides this, they then said, okay, guys, you get this special permission for Apache Solr. 1 month into the project, we realized, okay, we need to store some files. So again, guess what? We had to talk to these guys. And what did they say? You have to use an Oracle database. So again, and then we said, yeah, but we only want to store files. Why don't we just stick it into a file system? That's what it's made for. Why stick binary data into an Oracle database? And the answer was basically, well, we have that hugely expensive enterprise license, and right, this is kind of the governance decision. You have to put all your data into an Oracle database. Guess what? We didn't. We used a file system, and I guess after that time they didn't really like me anymore because they had kind of the impression I do what I want, which I don't think that was quite kind of fair. But we tried to reason and argue. Then at some later point, we introduced a Spring Boot, because back then we should have used J2EE as the framework, and that was kind of outdated back then already, right? You had like Spring Boot 2.5 or something. So I see I was kind of a rebel back then. But I understood their point in a way, right? They wanted to kind of reduce the amount of technology that is within the organization. They looked at it from a maintenance point of view, maybe, right, from a technology footprint point of view. And in all fairness, this is a valid point to look at this, but also if that kind of hinders you to implement like state-of-the-art innovative solutions that are kind of up to other quality attributes, right? Maintainability is not the only one, then that's not really good. Now, times have changed, right? No one's doing waterfall anymore. Also, these corporate enterprises, these huge organizations, they've also changed. They introduced agile methods, big methods, so not like Scrum. So mainly they use either SAFe, so these large-scale agile methods. And all good. I mean, made our life easier as developers, as architects, because what happened to those Ivory Tower architects? Well, basically they got another job. They've been put somewhere else. Maybe they could give some advice, but they were definitely not the last governing body anymore that kind of could decide for you. So the pendulum went from that one end to the other extreme. And I call that other extreme basically the, let's say this is the Agile Wild West, right? Because what happened, everyone was doing what he wanted. Mainly because I think they misunderstood the Agile Manifest, where it says things like individuals' interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Now, there miss, in my opinion, many teams, and I still do a bit of consultancy and a bit of reviews on, let's say, failing projects. And usually the case is that, well, that part here over comprehensive documentation, I mean, that has been misinterpreted into, well, we don't write any documentation anymore, sucked anyway. Who wants to write documentation, want to write code? Following a plan, also not there anymore, right? If you ask a developer in these non-functioning agile projects, so when you're done, well, I'm done when I'm done, right? Ask me the next sprint. Maybe it's done then, right? And a bit of planning is usually a good thing in my opinion, but no plan at all. And definitely no processes and tools, so at least no standardized processes and no standardized tools anymore. Everyone did what he wanted, and there we go, the wild Agile West. You know, different teams, different languages. The one is using AWS, the other team is using Azure. Python, Kotlin, Go, Node.js for the really crazy ones. Node.js on a server side still gives me gray hair. So, right, mad. Postgre, Mongo, you name it. All the technologies are pretty much out there. And for most of the clients I saw out there, that posed a huge problem. Because now suddenly the technology footprint within this organization was huge, was unmanageable. Problems begin to appear, security issues, for example, right? With one technology, it's pretty easy to have an eye on security-related things. If you have like 10 different technologies, well, all these ecosystems work slightly different. This meant a lot of work. No documentation anymore. So teams obviously change, right? Bit of documentation usually is kind of a good idea. So most of these organizations, they had a big problem. Hopefully not now anymore. But let's say back 7 years ago, 5 to 7 years ago, most of these organizations realized, hey, maybe we should put that pendulum, that lever somewhere in the middle, right? Not everything from the good old times was so bad. And while we kind of exaggerated it into the naive agile way, that is also not so good. So maybe we find the golden middle. So architecture in these projects usually looked like this house here, right? Well, it kind of worked. But in production, errors, instabilities, insecurities, you name it. All sorts of problems. And last but not least, maybe that's another thing. Are there any Agile Masters in here? Then I have to, okay, then I have to be a bit careful what I say now. You do 1 week sprints. The thing is, I've met in my career a few Agile architects that sit in their ivory tower now, and they don't care about the people, they only care about the process, right? And they only say like, yo, it has to be 2 weeks because I'm a book, it has to be 2 weeks, right? So I see you not nodding, so luckily it's different, right? But I've seen this also, right, that you don't have the ivory tower architects anymore, now you have those Agile guys that say like, no, it's not flexible, I don't care about the technology, I don't care about the people, it's only the process, right? Also not good, so don't go that route, please. Now, let's come to the first, let's say, practical advice I would want to give you. Is anyone in here using Arc42 as his documentation? No one. Then I advise you, or urge you, or recommend you, have a look at this one. It's a super lightweight, kind of standardized structure, document, developed by Gernot Starke, is a German, also computer science professor. That's kind of known, at least in Germany. And he developed that one. And basically, if I say lightweight, you get that document as Markdown files, as ASCII doc, if you like, Confluence, if you like, templates. The basic idea is write that document, put it next to the code, if you like, right? Check that into Git or GitLab or whatever you have. And the document lives. Next idea is you don't have to write everything at the start. There are a few initial chapters that you need to fill, something like introduction goals, for example, constraints and the context and scope. That kind of outlines the general idea of why are we building this piece of software, this microservice or this macroservice or this monolith or whatever, where you write something about your functional requirements, especially your quality goals, both is important. What's the context and scope? So which external systems and interfaces are there out there? Down here, you have the quality tree and some quality scenarios. Also, so these 4 chapters, I at least tell my students, these are the first ones you should write. Because these set the scope of everything else that comes later. Then solution strategy. So what are the core ideas and solution approaches? So, right? Maybe you say like, hey, we do microservices, we do function as a service, whatever. So what's the structure of the source code? What's the modularization? Rough building block view. What are important runtime scenarios, right? So have a look, take a conceptual look at the system you want to build, take a technical look onto the system you want to build, and also take an infrastructural view on the system you want to build, right? So these are usually the 3 views when I describe a system that I think are essential. And deployment, obviously, so runtime and deployment. Cross-cutting concerns, and here, if you do, then write down some architectural decisions. The early ones, right? This is obviously going to change over time in Agile projects, right? But the early ones, there are some early architectural decisions. I usually like to say, I don't know if he invented that one, but I remember a great talk by Neil Ford. He always said, like that the stuff that's hard to change later, that's the stuff you should document here, right? So maybe which programming language you use. That's kind of hard to change later. It's possible, but hard. A lot of work. And a previous speaker said, like, with the Markdown documentation, there is kind of the trade-off. Where do you put that? Do you put it in the repository, for example, or do you put it into a central Confluence page? This is what my colleagues use to synchronize both worlds. So we have both. We have a central Confluence. Due to compliance reasons, we have to document everything in Confluence. But from a developer perspective, it's kind of nice to write Markdown. And down there is a bunch of Maven plugins you just stick into your CI build or into your Maven build. You have a CI pipeline running and then basically continuously upgrade the Markdown documentation with a Confluence page, and you're good to go, right? So you don't have kind of a skew between the versions. Now you might say like, ooh, I have to write documentation. Please, this should not be more than, I don't know, 6 A4 pages if you will print it, okay? Stay lean, focus on the most important stuff, start small, and continuously evolve, right? Don't write too much because, as usual, if you write too much, then the chances that it gets outdated in certain sections they're pretty high then again. But I think this is a good and important document. Don't underestimate the glossary, for example, right? So this is kind of where you have like the most important terms that should be reflected and manifested inside the code as well. This is kind of the ubiquitous language, if you would call it from a domain-driven design, right? This is where your glossary should be. What are the most important terms? And I urge you, maybe this is a bit puristic, but before you write the first line of code, start with that document. These should be the first files in that repository, and then you start write code. Now, I said before, I'm a teacher of software quality assurance. So let's have a look at this, maybe slightly outdated norm, ISO 2510. And the message is holistic software product quality is a lot of work. And the big question is, which ones are more important? I guess nowadays, 2024, security might be very important as a main attribute, integrity, authentication, accountability, confidentiality, probably somehow all important. Functional suitability. This is mostly important for our end users and maybe for our product owners, right? We need to make sure that we build the right system, right? This is the functional requirements. Are they complete? Are they correct? And are they appropriate for the problem? Usability. If you ask a product owner, probably that's the second most important thing, right? He wants a nice, fancy user interface. It needs to be accessible, right? Accessibility this year, I don't know, July, really big thing in the EU. Maybe not here in the UK anymore, but at least for the rest of the European Union, there is a new law on accessibility. So there is actually something to be compliant to, right? We need to make sure we are accessible, needs to be operable, it needs to be learnable. So usability is a thing. We need to test for this. We need to implement things. Efficiency, maybe mostly important from an operational point of view, very important. Timing behavior, resource utilization, capacity planning. Reliability, right? Digitalization, all these big companies out there, they have digitalized their internal things, right? All these products. So reliability is important because if the system doesn't run, you usually don't earn any money, right? So kind of also important. How available are you? How fault tolerant are you? How recoverable are you? How long does it take to recover in case of an error? Maintainability, this is usually a developer perspective, right? Do we write good code? Is it modular? Is it reusable? Is it testable? Is it modifiable? This is definitely, yeah, this is where the techies are. Maybe compatibility in case of, systems evolve, you have different versions, how compatible, how interoperable are you with later versions or newer versions. And portability might be a thing, right? How portable is your system? I'll give you an example, right? For the systems we built for one of our customers, they have a hard rule. They say the system needs to be as portable as possible. In case of cloud providers, you need to be able to switch cloud provider within 6 months. And 6 months is not that long, okay? So you better do everything, at least, well, to keep the infrastructure out of your business logic and to keep the infrastructure out of your technology stack as much as possible, right? And just keep it on the infrastructure level so it's as portable as possible. Now, if you mean this serious, right? And I think with the latest revision, there came a few more. Safety, is it safe to use and is it deployable and operable and whatever? Now, if you do that seriously, this is a lot of work for the architect, for the developers, for everyone who's responsible for the project. Because if you say, functional suitability is something you cannot ignore, right? But there's a question.
Yeah, safety and security. Deployability and portability, they sound like synonyms. What's the difference? Like
Safety and security is not the same. Please read the ISO document. Security is more from an IT security perspective. Safety is more from a perspective of the end user. Is it safe to use? Does it hurt anyone? Think of software that runs inside a car. Is the software safe? Or autonomous driving example, for example, right? Keep that in mind. I show you a different model in a second. This depends who you ask, okay? If you ask an ops person, then he's probably talking about deployability. If you talk about the portability bit, that's usually some governance body that says, like, you have to be able to migrate. They don't care if you can deploy the software within 5 minutes automatically on some infrastructure. This is not what the compliance guy wants. The compliance guy wants that you don't have a vendor login. So this is, in my interpretation, the difference between portability and deployability. So which one is more important? Functional suitability, well, we don't want to build the wrong system, so that's kind of there. We want to make our end users happy, so usability is also a thing. We want to make our ops people happy, so reliability and efficiency is probably a thing. We want to make our CISO happy, so the chief security officer, so security and safety is definitely a thing. We want to make our engineers happy, so we have to look after this here. And yeah, maybe these not so much, but the thing is, how do you prioritize? And the next thing is, how do you interpret these illities? That was always a problem with the standard. And here's a new way of thinking about quality that I really like. This is kind of the smaller brother of ARC42. Gernot Starke came up with something called Q42. And basically what he says is, if you talk to different stakeholders, things like, is it secure, is it safe, is it flexible, is it operable, is it suitable, mean different things, right? Is it secure, right? If you ask the user, then it is secure if, I don't know, you don't lose his data and your data is kept securely. If you ask your chief security officer, then secure means a lot more, right? Are there any holes, or do we have any CVEs in the project? Do we scan for them regularly? Do we have pen tests in place? Things like this. So depending on who you ask, these different, now not entities anymore, it's more attributes, mean different things, and they can guide you to then decide how can we address these different attributes, how can we address the requirements from all these different stakeholders for all these quality attributes, okay? So again here, have a look at Q42, and you can integrate that nicely into your Markdown documentation, have like build up a quality tree, and then say like, okay, reliability for my developers, or reliability for my product owner, or reliability for my ops people. I implement following things, or have following measures in place to enforce that these attributes are met. I talked about these different layers before. I don't know how you think about software architecture, or if you plan a system. This is how I was taught back then 25 years ago. And for me, it still works. For our team, still work. We have a conceptual view, a technical view, and an infrastructure view. Conceptual is more, it's about the functional requirements, it's about the data models you have, it's about the business domain. You may apply domain-driven design up here, for example, right? The technical one, this is usually, if you ask a developer, this is the type of architecture he considers architecture, right? This is, do I use the Spring framework, or do I use Jakarta EE? Do I do layers or onions or hexagon, right? Which open source components do I use? How do I stick them together? This is like where we architects and software engineers like, you know, feel good, right? This is what we want to do. We want to play, we want to code. In modern DevOps projects, I would say infrastructure is a thing. We don't throw something over the wall anymore, right? We need to build up infrastructure. So we also have to take care of how can I, for example, implement the non-functional requirements. How can I address these attributes in terms of infrastructure? How's the infrastructure structured, right? This can be as low as network segmentation up to, you know, what type of cloud services do I want to use? So hardware requirements, software requirements, operational components, what do I need here? And so all these software quality attributes can be found in all these layers, and you need to address them individually in these layers. Now, if you mess up here, I'm pretty sure you heard of the term technical debt before, right? I want to introduce another one. That is what I call domain level debt. And that manifests up here, right? This is basically if you build the system that does not fully comply to your functional requirements, right? Or to these attributes, functional suitability, for example. And this is kind of common, what I see at least often, in Agile projects. It's like these are use cases that are implemented only halfway, as an example, right? Because of some deadline that came up, and it's like, oh, come on, just release this MVP. It's good enough for now, but then, as usual, you know, business as usual. You keep on going, and you forget about the rest of the half you just didn't implement. Okay, so don't underestimate domain level debt. You can measure that. Usually, these are the to-dos in your code, or maybe the backlog in your Jira system that keeps getting bigger and bigger and bigger, and is probably labeled somehow. These are then the stories that make up the domain level debt, and obviously the technical debt, right? Libraries that are outdated, wrong license, the layering or the architecture is not, you know, you decided to implement hexagon now. Maybe you had a junior developer who else, doesn't really matter, kind of, you know, screwed up the architecture. So if you do not monitor this here and do something against it, then obviously as time flies, the system will, your architecture will deteriorate. Next one, I guess I heard Simon Brown talk yesterday, so this is a really good one. I hope you've seen his talk. I think it's probably recorded. It's a bit of documentation, but I think it's always good to have diagrams. Something that is definitely used in all our projects is that what Simon Brown proposes is diagrams as code using C4. at least the first three. We don't use the fourth layer, but to, right, there's always says like an image is worth 1,000 words if it's a good image. So if it's, you know, if it's concise, it doesn't use too many symbols, things like this, if they're well structured and layouted. But the general idea is to have like this analogy of these landscapes. You have like the context view, right? You have that context view. This is kind of the most high-level view on each of those boxes. You can then perform a double click. Then you get into your, what is it, the architecture helicopter and fly one level below. Then you are at the component, the container layer, right? You have a database component or web app component or a SPA component with all those interactions. And then you can even fly one more lower and do another double click. And then you are on the business component level, right? Business or technical component level. And that's usually good. You can generate that from code. You can generate it with code. This is all our developers like that approach. So definitely good working. Unfortunately, there is no possibility to draw nice infrastructure diagrams. So I brought you another option that some projects use. I mean, there are tons of open source projects out there that can kind of do the same. But what I want to say is, if you give a developer this capability, write code, get fancy, nice diagrams, everyone will do that, right? Where the Visio users, who's used Visio, right? Even more gray hair, right? So this is fun here. Write code. I've even seen internal projects at some customers that implemented them themselves because they didn't like Python. They wanted to use TypeScript. I mean, do whatever you like, but draw good diagrams that explain the system. This is really good for the afterwards for the next developer that joins a team. But diagrams as code, as an approach, definitely works for all our projects. Next thing. Now, we said we only do the initial architecture at the beginning, and the other architectural decisions that come that may come throughout the lifetime of the project, they come later, right? So you need to decide at some point. And the good question is, at which point? And I urge you to use the last responsible moment and not the last possible moment. Okay? Last possible moment is not very responsible anymore. And the idea is very simple, right? I mean, you know that you have to take a decision in the future because you see, hey, there's something deteriorating, we might have a problem in the future. The longer you wait, the more context you have, the more knowledge you have, and that context is important to make a good decision, right? But at some point, if it's too late, then bad things happen, right? You miss a deadline, or the complexity gets too big, or the amount of work you have to do a big refactoring gets just too big, and then maybe you have a budget problem. So here are a few useful questions, right? Do you have to take the decision now? Can we postpone the decision? That sounds kind of lazy, but it's a really important question. What are the consequences of postponing it, right? Talk to your product owner, talk to your teammates, maybe talk to other architects. So what happens if you postpone it? When will the overall complexity become too high? Are there any alternatives? Also a good idea, right? What are the trade-offs of our decisions, and can we revert a decision, right? Decision can also be maybe not so good. Now, this sounds awfully heavy. I would say be brave, have no fear of suboptimal decisions. I'm pretty sure we're all capable at the moment to do a really good decision, right? And in 3 months' time later, maybe it turns out it wasn't such a good idea, but back then it was. But then I have more context, right? And if I may have an alternative in my pocket, or maybe I can revert the decision, then nothing really happened, right? And we do iterative development, we do test-driven development, we have refactoring capabilities, we have continuous integration and deployment, we have architecture fitness functions, maybe. All these help me to at least monitor my decisions and to see was it a good decision or not, right? So have no fear. There are no suboptimal decisions. I guess at the time we take the decisions, I think everyone is able to do a good decision, a well-informed decision. Also, it took my teams quite a long time to adopt this here. Previous speakers already talked about architecture decisions. I found it quite funny that it's super old, and back then we just called them decision records. I see here in the third line. And you see that this blog post from Michael Nygaard is already pretty old, November 15, 2011. Whew, that's Stone Age in computer science already, right? This is a long time ago. But I really like this post because he writes, right, in agile projects work differently. Not all decisions will be made at once, nor will they be all done at the project when the project begins, right? This is the reality we have. And then he says, if we don't do that, if we don't track all our decisions, then only two things can basically happen. If a new developer comes into the project, or you, right, because you just forgot, because why did we use Mongo database in this project? Well, if you don't document it, no one knows anymore. So I have two options. Either say you blindly accept it, well, it may be okay, but maybe times have changed and it would be a good time to kind of revert that decision and go a different route. But since you don't know what was the context back then to make that decision, then you can, well, the basic thing you can do, you just accept it and say like, okay, well, just continue that way. Or you just blindly change it. That may also be okay, but also it may not be so okay. So it's definitely better to avoid either the blind acceptance or the blind reversal of things. So we need to document these things somehow. So this is taken from the ThoughtWorks radar, where they just have a quick definition of ADRs, right? Keep them short, and this is what it looks like, right? Give it a brief title, number them, write down the context, okay? What is the current problem context? Maybe state your alternatives here, okay, here in the context. Then write down the decision. We will use AWS as our infrastructure provider, as our cloud provider. We will, I don't know, implement this system using an onion architecture. Status, proposed, accepted, deprecated, superseded, right? So you see deprecated, superseded, that kind of tells you that things can change, right? Some decisions are then deprecated. It's not the former decision anymore. They can be superseded by other ADRs. And obviously write down the consequences, right? Every decision comes with a consequence. Now what they propose is put these ADR files in the same repo. This is not what we do anymore. We have a dedicated repository where for all the teams, there's one dedicated repository where we kind of document all these. Don't write too many, okay? Because otherwise you will have a maintenance headache with these ADRs because, right, you need someone to look after these things. But for the teams that for our teams that have adopted this approach, this is a really good thing to kind of communicate also the architecture decisions within the teams. Because this here, writing these is kind of a team effort. There's kind of an architecture meeting every week. And then they say like, hey, are there any decisions that need to be taken? Okay. Then they do a bit of research. And for the big ones, for the really important ones, they then write an ADR that is kind of then mandatory or binding for all the other teams that are part of this product. Next thing is architecture fitness functions. I guess you've heard of these already. Comes from a book called Building Evolutionary Architectures, where this was definitely proposed. And the basic idea is the following. Now, if you have your software quality attributes, you can define some functions, and a function can be an automated thing or a manual thing that kind of regularly checks, do I still meet my quality requirements? Because if you don't measure, you don't know, right? So you need some form of measurement. And we kind of implement these for, let's say, the big projects, because as an architect for, let's say you have a team of 65 developers, you have most of them do microservices. And as an architect, it's kind of difficult to look after 350 different repositories into several components and kind of see, did we mess up in one of these components? Okay, so you need to automate this somehow. And that is, in my opinion, the idea of these architectural fitness functions, right? And put these into, well, unit test, some form of unit test. So maybe apply fitness function-driven development, gather your requirements from all the stakeholders, like before, business, compliance, operations, security, infrastructure. Usually these are exactly the ilities we talked about before. And then maybe use some behavior-driven tool, like, I don't know, Cucumber or in whatever language you prefer, and formulate these requirements as a test, ideally, if you can automate it. Not everything can be automated. And then just put these tests into your standard CI pipelines and just let them run, okay? And then you have your standard procedure here, unit testing, build, deploy, integration testing, end-to-end testing. Then you have all these fitness functions, and if they're all green, then you can promote. Then you are sure that you shipped good changes into the next stage, into production or whatever, right? Here are a few examples. So for code quality, for example, that is the maintainability bit, right? Modifiability bit, adaptability bit. Let's say you continuously measure using SonarQube or any other static code analysis. You measure the code quality. So what you could do is you could formulate an architecture fitness function that says, hey, the test coverage needs to be above 90%. Expect quality, get test coverage. So this is the hard bit. To be honest, you need to implement some piece of code that kind of then queries the data source where you can extract that data. And for the maintainability rating, we want to have something higher than B. Looks straightforward, right? It's readable, it's good, you let it run continuously, and the build will fail if any of these conditions will fail. Performance, well, assuming you do regular load tests as part of your integration, and your performance tool dumps its data to some database, then you could formulate this. Or maybe you plug that into your observability solution you have in production, could also be. Completes a transaction under 10 seconds, has less than 10% error rate for 10,000 transactions, and again, a simple expect statement that kind of checks against a given threshold, or maybe a trend, right? Either a threshold or a trend may be sometimes more important. Scalability, stability. Security. You should not have plain text secrets in your code base. Hopefully not. You should not have any OWASP top 10 vulnerabilities. You should not have any CVEs or critical CVEs within your third-party dependencies. Again, you need some tool that regularly checks that, and that test then connects to that tool or that database or whatever, to that data source, and then that gives you the possibility to check. Observability is the same. Do I have a runbook? Do I have a README? Do I have tracing IDs defined? Do I have alerts defined in my monitoring solution to address manageability, operability, and recoverability? Now, the bad thing is, it's not a bad thing, okay? But here's a spoiler. I have not found any good tool out there that does that for us, okay? I don't know any open source solution that does that magically for us, okay? I show you in a few slides what we did to do this, okay? Because we implemented something on our own. So architecture fitness functions sound super sexy, but implementing them in reality is kind of super hard because I don't know any proper tooling that kind of holistically addresses that. Maybe you do. Then that would be interesting. Arch unit, very good. That's my next thing, yeah? But that unfortunately only covers the architectural part, right? And none of the other. But ArcUnit is the only real tool that you can kind of use to continuously validate, do I have cycles in my architecture? Is the onion architecture still in place, or the whatever the hexagon architecture? So the ArcUnit is the only good thing. Thank you for that. See here, ArcUnit. Unfortunately, only works for Java and C#. So if you are doing this in TypeScript, you are, I don't know, out. There is a TypeScript? Tell me. Is a TypeScript version nowadays? Okay, so there is a port in TypeScript, so TypeScript also addressed, right? I could name you a few commercial products that kind of do this. Structure 101 would be one, for example, that you could implement. But ArchUnit, super simple. I urge you, right? This is kind of 20 lines of code to continuously validate, does my code still comply to the Onion architecture, okay? So it would almost be negligent to not write this unit test here, right? Have a look at their documentation. This is super sweet. One thing I really like is if you use plant UML to textually describe your architecture, then you can, and to then draw the diagram, you can use the same plant UML definition to stick that into ArchUnit, and then ArchUnit will check your code against that plant UML model. Also pretty nice, right? It's probably only a 3-liner. So, software engineering insights. And this is what we have done, right? And this is an initiative I think I started 3.5 years ago myself when I was still on the project, where we had that problem of, oh my God, we have so many Sonar dashboards for each and every repository. We have so many CI builds. We have so many load tests out there. I mean, this system contains 75 microservices, a lot of utility library projects. So we talk about 350 plus Git repositories. And continuously checking each one of them, because their constantly changes everywhere, is a nightmare, right? And I don't want nightmare, I want to sleep nice, right? I want to get an email or I want to see a red light somewhere which tells me, hey, now is something wrong, have a look there. And this is what I call software engineering insights. And basically what we did is we use an InfluxDB plus Grafana. This is the base technology, right? Because InfluxDB is a time series database. We want to look at time data, at time metrics, each and every build, each and every change makes, changes things. So this is why we thought, hey, come on, let's use an Influx database. Now, the architecture is pretty simple. And this is what all our projects. So up here, you have the standard push build stuff, check out, build, test, maybe the first initial Sonar cube, maybe do a bit of, you do the Docker image building, you do a bit of scanning of the vulnerabilities. So in that stage already, loads of quality metrics, quality-related metrics are produced. Then we push that stuff. In our case here, the ECR, for example, also continuously scans all the images, for example. Again, even more data is produced. Then we deploy the stuff, Argo Flux. You see we're in the cloud world. We have a GitOps approach. There's quite some data produced here, all right? Does it fail? Did the deployment fail? Did it work? Deploy that down here, let it run. Then we have let's say the integration end-to-end test phase. So we use Cucumber, we use K6 for load testing, we use a framework called TestCube to continuously run all those non-functional high-level tests within the cluster, against the cluster. And then last but not least, this is now where the magic happens here. We have something called now a quality cockpit, where we kind of accumulate all the relevant data, okay? We have, we get some data from Jira, for example. What we basically do is we query certain labeled Jira issues, right? To track domain level depth, to track technical depth. We do that via Jira and special Jira tickets that are labeled appropriately. All the performance-related data, build status, code quality, test results. Here the performance data, we all dump that, we all push that into the database. And then we have a nice quality kind of dashboard that kind of on different levels of the system, we can drill in. And see, hey, is the system, in general, is the quality okay? If we see, oh no, it's not okay, then we can go one level deeper, right? Think about the C4 stuff, for example, context, container, component. So we can drill up and down and see the individual status. And then what you can do with Grafana is that you can define alerts, okay? And this is our fitness function, basically, where we, via a Grafana alert, we say like, hey, if anything goes below or above a certain threshold or trend, then please Slack message. In our case. So unfortunately, you have to build something on your own. The good part is it was not so much work, in all fairness. Grafana InfluxDB setup was really quick. Most of the stuff up there is implemented in GitHub Actions that extract the data and push it into the database. And down here, it's pretty much the same. Now, 1 minute left. I have to hurry up. So obviously, we make mistakes. We're humans, right? So we need some approach to kind of continuously check things. And the last bit I want to introduce is something called AIM-42. AIM stands for Architecture Improvement Method. It's kind of a structured approach to tackle technical debt, to tackle domain level debt. Take your time, once a month, 1 day. Analyze your systems, do code reviews, talk to peers, talk to your developers. Hey, which crappy code did come by your eyes? Where should we work on? Where should we improve the system? Analyze stuff. Then write. What we do is we write Jira tickets. Then evaluate the Jira tickets. Take decisions. Right? Maybe accumulate a few Jira tickets together because you say like, hey, that they are related with each other, and then improve them in the next sprint or in the next time. Okay. So have a look at AIM-42. It's a really lightweight, structured approach to make sure your software architecture stays in shape. Last but not least, I skipped that slide here. What worked for us is over each and every team, we have kind of what we call an enabling team. This is where all the architects continuously come together on a weekly basis. They make sure architecture is communicated within the team on a regular basis. They make sure that in each and every team the right things happen and that the decisions we made are enforced and implemented. Bit of book reading list. You get the slides after work anyway. Great books, definitely. And yeah, thanks. Time's up.